So for this session, this is going to be CCNP Class 6. We're on our second part of BGP. And so this is going to be a little different. We're using a different topology. Well, not different topology. It's the same topology, but we're dividing it up into three pieces. We've got BGP ASN in the center here, ASN 100. This is going to be running OSPF. On the left-hand side, R1 and R2, we have ASN 200. And on the right side, we have ASN 300. That's on R6 and R7. So you're in the center here. You're connected to two ISPs. Okay. So in the last session, all we did basically was neighbor up with BGP. In this one, we're going to have a little bit of review. We're going to go back into neighboring up with your external peers. So R3 to R1 and R5 to R6. We're going to do a couple extra commands. And then we're going to neighbor up internally between R4, R4 to R3, and R4 to R5. Then we're going to throw a couple networks into BGP. And then if we have time, we'll get into regular expressions. And of course, if you have any questions at any time, just go ahead and hit me up on the chat or unmute your mics and just holler out. Let's begin. Okay. Task 0, we want to peer up with our service providers. We're assuming that OSPF is good on the internal network, so we should have no problems there. We're also assuming that basically we cannot configure or go on our service provider routers. So R1, R2, R6, R7, we can't touch those guys. We're assuming that they are already configured, which they are, or they should be. So on R3, we're going to be pairing up with R1's loopback, which is all ones, and the BGP ASN is 200. So just keep that in mind there. Now before we do that, we want to try out this new command. I don't know if it's new. I'm not sure if I told you about it last week, but it's debug IP BGP. We're going to start that on R3 and R5 for now. Just type in debug IP BGP. Nothing's going to happen just yet because you don't have BGP anything running, so it's just going to sit there. And we'll go on R5. So get that debug running. And if you ever forget what debugs you have on, just do a show debug, and it'll tell you what you have running. So it says BGP debugging is on. Okay, now we're going to configure our peering, conf t. Our ASN is 100, so that's us. And remember, this is external BGP. You're connecting to another autonomous system. So things are going to be slightly different than iBGP, which we'll do in about 20 to 30 minutes. So it's neighbor all ones. And then his remote AS is 200. Okay, we'll probably need two more commands to get this up and running. Who remembers these two commands? So we need one to kind of specify that we're coming from loopback 0. Update source, yeah. So neighbor all ones, update source loopback 0. And then we're going to need another command because eBGP peering usually has a TTL of 1. That means the packet dies one hop away. So what do we do to make those BGP packets last a little bit longer? So multi-hop 2, yeah, that'll probably work. So eBGP multi-hop. So what if I leave it just like that and I hit enter? What's my hops going to be? What's my TTL? 255, correct. So neighbor all ones, eBGP multi-hop 2. We'll end it right there. We have our debugs on, so let's see what happens. Cool. Looks like we've got a couple debugs. Let's see. We have received an open message. It's coming from the other side. Got all these different capabilities. You don't really need to worry about this, but basically what happens is the two BGP routers are saying, okay, I can do this, I can do that. Route refresh, this is where you could do like clear IP BGP soft in, soft out, that type of stuff. So they're basically comparing their abilities. And then finally down here, you'll see that it went from open confirm to established. So basically all the parameters match and then our neighbors come up. Show IP BGP summary. And right here, you're seeing that we are getting 6 prefixes already from our service provider. And we can show IP BGP to take a look at our prefixes. And these are all the prefixes coming from ASN 200. So they're going through 200. They could be starting somewhere else, but for now they're coming through 200. And it gives us our next hops right there, all ones because it's coming from router 1. So I should be able to ping 98.101, 98.111, 98.121, and you get the picture. All right. Any problems with getting a eBGP peering between R3 and R1? That should be review from last week. Yeah, it should be pretty simple. Okay, go over to R5. Conf-T. Almost the same thing. We are ASN 100. We're going to be neighboring up to all 6s. That's going to be router 6's loopback, remote AS 300, neighbor all 6's update source loopback 0, neighbor all 6's eBGP multi-hop. Here I'm just going to hit enter because I'm lazy. And we have our debugs go crazy, and you can see our neighbor is now up. And I can show IP BGP. And you can see I'm getting some prefixes. Let's see, it looks like 7 prefixes coming from R6 ASN 300. So nothing too crazy going on there. Let's take a look at our tasks. So we've gone on R3, configured peering with R1. R5, we've configured peering with R6. We know we're receiving prefixes. Staying on R5, you can show IP BGP summary. It'll tell you you're getting 7 prefixes, so that's good. And we're jumping the gun just a little bit, but if you show IP route, let's take a look at your routing table. And so you know that inside your central triangle you have OSPF running, and that's why you are seeing these O routes. You're learning R4's loopback through OSPF. So notice for everything that is static or an IGP, you've got a next hop and outgoing interface. So if we go down here to, let's see here, your O route here, you'll see something like going out fast 01, going out fast 00. And it also says via, so this is your next hop. So next hop's 1010 45 4. You should see in your routing table. Now if you look at your BGP routes, what's different about your BGP routes versus your other routes? Can you spot the difference there? So I've got the one of them highlighted. There's a couple differences. There's two that I'm looking for. So it's via 6666. Okay, yeah. It's coming from the loopback. Okay. Administrative distance is 20, so that's good. What about on the right-hand side? Giving you a big hint there. What are we missing on the right-hand side if you're looking at BGP? Let me highlight something in one of these OSPF routes. Some interface. Yeah, so OSPF is telling you, okay, I'm going out interface fast 01, fast 00. When you're BGP, BGP doesn't actually send you out an interface. BGP is going to tell you, okay, I would like to go that way, and now I want your OSPF, your IGP, or a static route to figure out the rest. So it's going to do a couple lookups to get to the final answer. And so this is where BGP is definitely different than OSPF, RIP, EIGRP. Right. So you're getting something from router 6. So router 6 is saying, hey, if you can reach me, I'll take you to 201.1.00. Now it's up to you to figure out how to actually get to me, whether it's OSPF, a static route, or something. So it's a little bit different thinking than all the other routing protocols. Okay. Show IP BGP summary. We see that we are neighboring up with R6, so that's cool. Now if we take a look at our diagram here, you'll see that we have a peering here and we have a peering there. So that's great. R3 can see stuff coming from R1, R5 can see stuff coming from R6. Probably might be good to have R3 and R5 talk to each other, right? Also might be good to have R4 talk to R3 and R5 as well. So we're going to be doing that in just a couple minutes, because right now this is just kind of in a vacuum right here. Okay. Well, let's take a look at some of these questions. We know what prefixes we're receiving, so that's good. And we can tell what ASNs they've passed through. We definitely can. So if we go back here, we'll go on R5, show IP BGP. We definitely know from this path here that on this particular one, 74.125, it started off in 15.169, went through 300, and then came into 100. On this guy right here, this 200 network, it started off in ASN 300. There are a couple websites where you can check out like the longest path that's ever been made. I think there's some crazy ones that have like 20, 30, 40 hops in there if you look up the paths. And that's just, sometimes it's just Cisco engineers screwing around just to make like a long, really, really long path. I think if you want to get a good example of how bored people can get, there was a guy who made the trace route to a particular IP look like the Star Wars intro. I don't know if that's still up anymore, but it was up like 3 weeks ago, I think. We got DDoS. Ah, that sucks. Okay, what are the dangers of pairing up with two service providers? So for this, let's think about this for a second. We're paired up here, so we're connected to the internet right there. We're also connected to the internet right here. So that's all in good. Now let's say we link these together. So we do some iBGP peering right here. What potentially could happen for us? Let's say our links is, let's say we have 1 meg links right here, right? Nothing too spectacular. We got 1 meg links. So we peer up externally, we start advertising some stuff. What could happen is we become a transit provider and traffic's going to flow right through us, which would basically kill our links. Now, why does this happen? Who knows how BGP decides to route traffic? What's the main thing BGP looks at when you're sending traffic from one network to another network? Does speed come into play? AS hops, yeah. So if for some reason, so this is dangerous now, because now that you've linked these two up, you have a possibility of making AS200 really juicy for AS300 and also vice versa. Because in the background here, there's other networks, lots of other networks. Let's say there's that many networks, and ASN 200 connects to 300 through this. So what used to be 7, 8 hops, you've now reduced it to 2 hops. So now ASN 300 goes, wow, I can reach ASN 200 2 hops away. That's awesome. I don't need to go this long way around, even though these are like, 10 gig links or whatever. I'm going to take the short way. So we could potentially become a transit provider. But then in the next class, I'll show you how to filter that stuff out so we don't become a transit provider. So there is a very long set of rules that BGP uses, and you can actually search on Cisco documentation, and they've got the full table out there. Okay, last question on task 0. So it is possible that our provider could send us 400,000 prefixes. So it's actually more than that. That's on the internet routing table. So we have to think to ourselves, how could we prevent that? And that leads us into task 1, where we pretty much assume that if our provider sends us 400,000 routes, we're dead, right? We don't want that because our router is pretty crappy. So let's go on router 3. So we know that router 3 is getting, should be 6 prefixes, 6 or 5. Looks like 5 prefixes, 6. 6 prefixes right there. So let's say we want to stop the number of prefixes at 10. We want to receive a maximum of 10. That way we just don't get hammered by our service provider. Now, almost guaranteed your service provider is limiting prefixes that it's receiving from you. So if you try to send your service provider 100,000 routes, they're going to cut your link. So it's only fair that we do the same thing back to them. This is a very easy command. Just go on router 3, conft, go back into BGP, router BGP 100. Neighbor statement, you're going to go to neighbor all ones and just type in max. Hit the tab button and it'll say maximum prefix. And this command doesn't have to be the same on both sides. You can have it on your side. Well, you couldn't configure it on the other side because that router is owned by the service provider. So we're going to say 10. Maximum prefix 10. You've got a bunch of options here. You could do question mark. So the 3 options, warning only, just says, well, when it goes over 10, your logs will say warning, warning. It's gone over 10. It's not actually going to kill the route. Now this default right here, if you just hit enter, when you hit 10, it's going to shut down the link. So warning only kind of circumvents that. Restart, ooh, no one's going to like you if you restart. So just like it says right there, when it goes to 11, it's going to kick over that BGP connection. You're going to be in a world of hurt with that one. And then putting in a number that's a percentage sign where you want the warning message to start. So if you're saying you can reach a maximum of 10, it doesn't make sense to just have a hard number 10 and hit 11 and die. That's not cool. What you probably want to have happen is when you hit 5, you want to get a warning message. So 5 is 50% of 10, so we would do 50 right there. And you could keep adding stuff. But for now, we'll say maximum prefix 10 space 50. So you're saying I'm going to allow up to 10. On the 11th one, it's going to die. And then starting at 5, which is 50% of 10, you're going to start getting warnings. So let's hit enter right there. See what happens. We'll end right there. And let's try this. Let's do a clear IP BGP star. Bad command to use in real life, but we're in a lab. Okay, we're going to kick over the connection. And 6 prefixes should come in. Debug IP BGP. Let's show run. Okay, so we got our router BGP, neighbor all ones, remote AS200, maximum prefix 10, and we have a 50 in there. That should be good. Show IP BGP. Now let's lower that a bit. Router BGP 100, neighbor all ones. Maximum prefix, let's get all medieval on this guy. Maximum prefix of 1, just to see if that command is even taking. And so that seems to work. You do a maximum prefix of 1, it says, well, we're downing everything. And you can see it's now in the active state. Let's see if we show IP BGP neighbor all ones. Let's see what happens here. And you'll see that maximum, whoa, kill that debug. There you go. Okay, so that show IP BGP neighbors command with all ones says maximum prefixes allowed 1, threshold for warning messages 75%. So that's the default 75%. And it tells you when you had a reset. So that's pretty cool. It tells you why as well. You hit the maximum number of prefixes. So we can change that. Go back into router BGP, neighbor all ones, maximum prefix, let's say 6. Show IP BGP summary. And also right here you can see that we're in a idle state. This thing in the parentheses, prefix count, means you went over. Okay, I set it to 6, clear IP BGP star. Let's see if our peer comes back up. And we're going to wait because BGP is slow as hell. And we're up, and now here you see the warning. So it's saying I've gotten 5. The maximum is 6. And now I'm right at the limit. So if I get one more prefix, I should die, because that's the maximum I am receiving. All right. Any questions about maximum prefix on R3? Yeah, I think we showed that when I did the 1. Router on your side is going to die, and then it says prefix count when you show IP BGP summary. And on the way, you're going to get a bunch of warnings. If we show run, got maximum prefix of 6, so that means we'll actually be okay all the way up until 6. So it's on that 7th one that it will go kaboom. Okay, let's go over to R5. R5 can receive a maximum number of prefixes. We're going to set it to 3 and see what happens. Let's go over R5, router BGP 100, neighbor. It's going to be all 6s. Maximum prefix 3. Now we're getting 7, so this should die. And as you can see, that went kaboom. Show IP BGP summary. It's going to be idle, and if we wait about 30 seconds, that idle is going to turn into idle / prefix count. Now that's active. Yeah, wait about 30 to 60 seconds more. And eventually that will change just like we saw in R3 when we changed the maximum prefix to 1. Probably should have changed the timers to make this go a little bit quicker. Okay, so you can see right there, idle, and then parentheses, prefix count right there. And just so we can continue, let's undo that command. So just hit the up arrow a bunch of times, get back to that command. Control A, pop a no in front of there, and you'll be okay. And we should be back to normal on R5 to R6. Okay, so that's task 1. It was pretty easy. It's just messed around with maximum prefixes. Self-protection mechanism. We talked about the options. There's some warnings in there. There is a default warning at 75%, but you could set different warnings. And remember that if you set a maximum prefix of 5, you will accept all the way up to 5. You will take the 5th one. But when you go 1 above, then it dies. And the problem that maximum prefixes is supposed to solve is basically so you don't screw up. What do I mean by screw up? Let's say on R4, it's either you or the service provider. But let's say on your OSPF network, if we show IP OSPF database, so you've got, you don't have anything too interesting. So you got pretty small database. But let's assume that in your network you had 5,000 servers. Let's say in addition to 5,000 servers, all of those servers were VMware ESX servers, and you had 200 servers on each one of those with multiple VLANs. So let's say you had 50,000 routes. You know, you're like The Planet or Software or something like that. And you go on R5, you're in BGP, and you decide to type in redistribute OSPF 1. Now, without the maximum prefix command, what's going to happen to the internet as soon as you hit enter right there? If I throw in all my OSPF prefixes into BGP, and I'm already paired up with R6, what's going to happen? It will throw in your OSPF routes into BGP. It will try to fling them up to R6. If R6 doesn't have any precautions configured, then that will fly out to the internet, and you know, there's going to be lots of fun happening. So you might get a nasty email from your service provider, but the maximum prefix command is the thing to stop that from happening. It's to prevent screw-ups, or one of the ways to prevent screw-ups. Okay. Any questions about maximum prefixes? Really simple command. And the way to see it on your router, show IP BGP. Show IP BGP neighbors, all ones. maximum prefixes allowed. It's kind of buried in there, so you might want to do show IP BGP neighbor all ones pipe I max. Oh, let's see here. With a capital M. There we go. Show IP BGP neighbors pipe I, filter it out, look for the capital M maximum. And it'll tell you if you have any maximum prefixes allowed. Okay, let's continue. Let's have some fun here. IBGP peering with R4. Actually, before we do that, let's take a look at our topology. So in red, we have this configured, this configured. Let's peer up between R4 and R5. That way we start flowing BGP in between R3 and R5. So this is going to be IBGP peering. Before we do that, let's go into R3, show IP BGP. Just take a look at what you have. Go on R5, show IP BGP. Let's take a look at your table. And so now let's peer them up. So you always want to have a before and after picture. So router BGP 100, neighbor, you're going over to R5. His autonomous system, same as yours. And change that update source to loopback 0. And you should be okay. Go over to R5. You're going to configure the return traffic, not return traffic, but the return configuration, the mirror image. All threes, remote AS 100. Update source, loopback 0. See, they go active. Give it about 30 seconds to a minute. They should start talking. There we go. That's the capabilities that they talk to each other about. I can do this, you can do that, all that good stuff. And then finally it goes to established and our neighbor is up. And life is good. So let's take a look at our BGP table. Oh, it looks a lot different now. Right? Go over to R3, show IP BGP. So let's see the difference. So before, you were only getting BGP information from router 1. Kind of makes sense. You were only peered with router 1. Now we have peering with router 5. And notice that the next hop is all 6s. So that's coming from router 6. Now you'll also notice this. You don't have a caret here on these 200 routes and this, some of these, the 74 routes coming from 6. But take a look at this 200.110. There's no caret there. So we did not use a command called next hop self. So we didn't mess with the next hop. So these prefixes are coming from R6. Comes from R6, hits R5, R5 chucks it to R3. So it still has the next hop of all 6s. Now here's a question for you. Can R3 reach all 6s? Yeah, so if we show IP route, let's see, I don't think we have all 6s in there. If we try to ping it, it'll die, right? So we can't hit the router that's telling us the information. So that's why we're missing that caret. Now we have the similar situation on R5. If we look at those 98 routes, 98.100, 98.111, same thing. R5 cannot hit R1. That's because we did not change the next hop. So by default, iBGP peering does not change the next hop. But we can. And actually, in most instances, it's probably a good idea. So on R5, router BGP 100, hit the up arrow until you get to neighbor all 3s. It's going to be next hop self. Boom. Go over to R3, conft router BGP 100. Hit the up arrow a bunch of times, neighbor all 5s. Next hop self. Clear IP BGP star. And let's wait about 40 seconds. And then we'll take a look at our BGP table. Show IP BGP. Yeah, we got some carets in there. Yeah, good. So now, instead of all 6s, look at that. Next hop is changed to all 5s. And I can hit all 5s because I can reach them through OSPF. So that's good. So now if I try to ping that guy. Okay, now it looks like I'm still dying. We're going to need to troubleshoot that. But at least I can get to all 5s. And we can verify that. Trace route 201.101. Whoa. 201.101. There we go. It's telling us we're dying at all 5s. Okay. So we're going to fix that. But at least we're getting the information through BGP. So that's the important thing. Okay. Now if we show IP route, let's take a look at how that seems. So it's saying for all these 200, 201 routes, we can hit them through router 5, so that's good. Okay, so R3 and R5 are paired up. We want to take a look at R4. Now R4 does not have BGP running at all. So we want to start it up. So R4, take a look at our topology. He's this guy up here. Now, why would you want to start BGP on R4? Let's think about this for a second. If you read ahead on our next task, we've got web servers on these links here. Now we don't have to start BGP on R4. We could get away with just leaving it OSPF. But in our case here, we're learning about BGP, so we're going to get a little iBGP extra practice if we throw R4 into BGP. So one of the things when you get out into real life world, just because you learn a certain technology doesn't necessarily mean that you're going to throw it everywhere. So just because you learn BGP doesn't mean you're going to throw BGP on all 500 of your routers. Just because you learn spanning tree doesn't mean that may be the best situation or best technology to use in some cases. In fact, when you're dealing with high frequency trading stuff, they recommend that you do not use spanning tree. And there's a couple white papers that you could read from Cisco about that. They do all these tests and they measure it out. And if you guys ever have time, look up the Nexus 3548 switch. So Cisco Nexus 3548 250 nanosecond. So look up the data sheet. It's got it's specially made for high frequency traders. It's got this thing called algo boost. So just for those algorithmic traders there. And so it's got some crazy low latency that helps those guys out. It's like $25,000 switch. Expensive. But in situations like that, what you learn in class is quite different than how they configure their networks. Okay, so back to R4. Let's actually configure BGP, router BGP 100, neighbor, all threes, remote AS 100. You can hit the up arrow, change that all threes to all fives. It's good. And neighbor all threes, update source, loopback 0. Hit the up arrow, change the threes to a 5. So BGP, you're going to be using that up arrow quite a bit. So you got R4 configured. What else do you need to do to get this to work? So in R4, you have the peering configured this direction. Now in this case, you don't need next top self because R4 is not getting any prefixes from an external neighbor. So the only place you really need next, well, you don't need it, but the two places where it's a good idea to put it on is R3 and R5 because they're connected to the outside world right here. So that's why we have next top self on those guys. But on R4, we get away with leaving that out. So we have R4 pointing to R3 and R5. What else do we need to do in our triangle to get this to work? Because I don't see any neighbors coming up just yet. Yeah, opposite direction, right? So we have to go on R3 and R5 and go backwards. Well, ping as well. Ping, because if you can't ping, then that's not going to work. It would be really bad if I was on R3 and I couldn't ping R4. Then we would have other network troubles that we would have to look into. Okay, so on R3, router BGP 100, neighbor all fours, mode AS 100, update source, loopback 0, and next hop self. Now without even going on R4, so not even looking at R4 just yet, as soon as my neighbor comes up on R3, what should I expect to see in the BGP table of R4? So would I expect it to be empty or would I expect it to have some prefixes in there? Should have some routes, yeah. should have some prefixes. So let's go to R4, show IP BGP, and we've got some stuff in there. Now, if you're on R4 and you want to make sure, or on any router, you want to make sure that a certain router is sending you prefixes. So if there's any question whether it's coming from R3 or R5, you can do this command, show IP BGP neighbor, the IP of the neighbor, all threes, and then the command advertised routes. So what routes are you sending to me? So look at that. It's kind of weird, right? Show IP BGP. Let's try this. So we see some stuff in our BGP table. Show IP BGP neighbors, all threes, advertised routes. Doesn't seem to give us anything. Okay, let's just do show IP BGP neighbors, all threes. Let's see if we updates. We're getting updates. We're getting 6 prefixes, so that's good. May have to turn in some other stuff. We'll configure R5 and we'll see if that changes. Let's go over to R5. Router BGP 100. Neighbor back to us. Load AS 100. And change that update source. And just wait for our neighbor to come up. Neighbor comes up. We should have sent him a bunch of prefixes, so show IP BGP. And we should have a pretty good table there. Oh, I think I forgot to do something. So on R5, I forgot to do next hop self. And so that's why the next hop is still at R6. Or, yeah, R6, all 6 is there. So just go back to R5, router BGP 100, neighbor all 4s, next hop self. So then we should be okay. Go back to R4, hit the up arrow, show IP BGP, and you can see that next hop has changed to all 5s, and now I have the caret symbol there. Okay, any questions here before we get into pinging these prefixes and doing some troubleshooting? Okay. So before, if you remember, I couldn't ping that 200.111 address. So let's see if we can ping it from R4. So ping 200.111. I see it in my BGP table. It's dying out. Right? If we trace it out, I get to router 5, and then it bombs out. So let's go one hop further. Let's go to R5, ping 200.111. I have a success. All right. So someone can reach it, but R4 cannot. So let's see what's going on here. First, let's show run. Let's take a look at first our BGP configuration. So let's see here. We have a neighbor, all threes, next top self, good. Neighbor to all fours, next top self. Neighbor to all six. Okay, that's our internet connection. Remote AS300, so that's good. We have OSPF configured. We threw all of our networks into OSPF. So that's pretty good. We have an IP route going to the loopback of router 6, so that's good. So let's take a look. Let's show IP route. And it was 200.110/24. So we know we can get there. We hit all sixes and we're good. Right. Let's see how that looks a little bit. Let's see the difference on R4. Show IP route. Okay, so we got that. 200.110/24. It's telling us to go to router 5. Okay. Now if we want to try to see what interface it's trying to get out of, we could show IPsef 200.111. Let's see what happens here. IPsef is saying go out fast 01. So definitely looks like it's sending it out, and our trace route confirms it, or else we wouldn't be getting a first hop there. Okay, so it is being sent out. Let's do this. Go on R5. So if we look at our topology, we're trying to ping from R4 going out to R5, and that 200 address is all the way down here. We are able to get out. Looks like we're hitting R5. R5 is going to check it out because it's got a route out. What do you think's happening on R7? What do you think's going on R7? R7, yeah, Raimundo's got it right. R7 has no clue how to get back to R4. Does not know how to get back to R4. So you can get out, just can't get back in. Now to verify that, let's say you call up the service provider. You say, hey, call up ASN 300. You call up their stupid techs who probably work on the other side of the world, and you say, hey, trying to reach 200.111, but you guys are down. And they say, well, it's up. We can ping it. What might you want to tell the guys at R7 to try? What commands would verify that the traffic's actually hitting R7? So assuming you're at the service provider now, what commands would you want to do to check to see if R4 can actually hit R7? So any debug commands we can run? Maybe show IP route. Well, let's go on R7. We're going to pretend to be the service provider. Go on R7. Debug IP packet. Okay, so we have debug IP packet. We go back to R4. Do that ping. 200.111. Send the ping. And we have the magical words unroutable. We have no idea how to get back. Right. Okay, couple ways we could fix that. That actually gets us into putting networks into BGP. Show IP route. We got 4 loopbacks. 1, 2, 3, 4. We have these networks that start with 100. 100 something. We're going to throw that into BGP because we want the world to know how to get there. So because we have them in our routing table, we should be able to put them into BGP. So this is on R4. We're going to tell the world about them. So router BGP 100 and then the network command. And we're going to have to match it exactly 100, 100, 0, 0. The word mask 255, 255, 255 dot 0. So before we hit enter there, go on R7, stop that debug, show IP BGP. So notice your BGP table. Go back on R4, hit enter, wait about 15 to 30 seconds. Go back to R7, hit the up arrow, show IP BGP, and look at that. You have got 100, 100, 0, 0. So now the whole internet can hit that web server at 100, 00/24. So it's pretty easy if we want to add in the other 3 routes. We can just hit the up arrow, just change that 3rd octet. All right, 1, 2, 3. And if we go over to R7, show IP route, or show IP BGP, those will slowly come in there. Remember, BGP is slow as hell. So BGP uses triggered updates. So once something changes, it's going to batch them up and it's going to send them out every 30 seconds.
Excuse me, Humphrey.
Yeah, go ahead.
Yeah, for some reason, when I use the neighbor, the 100.100.00 mask, I'm getting some type of error.
Okay, you're on R4.
Yes.
Let's take a look at your screen here. Waiting for Google to... Oh, you're typing in neighbor. So it's going to be network.
Ah, thank you.
Yep, not a problem. Okay, so after you have that typed in, show IP BGP, and yeah, so finally, after waiting about 40 seconds, I've got all 4 prefixes coming into R7. So now if I go back to R4, let's end out of there. We're going to do the ping, but we're going to have to make the ping come back to our loopback addresses because the internet only knows about loopbacks 1, 2, 3, and 4. Because this ping, it's going to want to come back probably on this network right here. Because it's going to send out the ping out the closest interface, or the best interface going out. And that address is going to be 10.10.45.4. And obviously there's not going to be any return traffic because the 10 address is a private address. So that's not cool. So we're going to have to change it up a bit. When we do the ping, it's going to be ping source loopback 1. We have a success. So the internet knows how to get back to us. It's kind of a tricky thing to realize. So for the internet to get back to you, you have to pop that into BGP. Or someone has to pop that into BGP so they know the return route. Let's see here. Earl, were you able to get that to work?
Yes, I did, Humphrey. Sorry about that. Thank you.
Oh, not a problem. Okay, yeah, we see some exclamation marks. Always a good thing.
No doubt.
Yeah. Okay. Now, there's another way we could have tried to play this. If we just pretend that the 10 networks can be reached from the internet, right? So let's pretend right now that the 10s aren't private. So if we go to R5, R5 has got some, if we show IP route, we've got all these routes in OSPF, right? So actually show IP route OSPF will show us just the OSPF routes. So we got all the loopbacks of router 4 in OSPF. We have all the inter-route or internal networks in OSPF. What if we did this? What if I took all of my OSPF, chucked it into BGP, and told the whole world? Now, I'm not saying that's a good idea. It's a horrible idea. But would that solve our ping issue without doing the network statements? So we want to tell the whole world about our 10 networks and our 100 networks. Well, let's try it. Let's do it. Once again, not saying this is a good idea. You should really think carefully before you do this. But, we'll go back here, router BGP 100. And we're going to kill those network statements. So 0, 1, 2, and 3. Right? Killed all those things. Wait for BGP to catch up. We're going to go to R5. And here's what we're going to do. Go on R5, router BGP 100, redistribute OSPF 1. Yeah, we could pretty much leave everything else for now. We just leave it right there. Soon as you hit enter here, Armageddon's going to happen because you're going to tell the whole world about your internal network. Okay. Let's go over to R7. Show IP BGP. Probably have to wait a little bit. Oh, yep. Oh, yeah. Look at that. Your whole internal network is now on the internet. People are laughing at you, probably DDoSing you, trying to hack you. They've already found your APC power units. They're already trying to go into your VMware servers. People are screaming. It's not good. But if you go on R4 and you ping 200, 1, 1, 1, you got a success. So, you know, you got a win there. You just had to hack off a couple fingers to do it. You know, if that's all your boss wanted, you're good. Does everyone understand that concept? Why the redistribution of OSPF gets you successful pings? And does everyone understand why this is a horrible, horrible idea to redistribute your internal network into BGP in most circumstances? Yeah, this is no bueno. You don't want to do this. Okay, let's go back to R5 and let's kill that redistribution. No redistribute OSPF. We'll go to R4. Pop those networks back into BGP. And you should verify on R7, show IP BGP. And those 100 networks will come in about 30 seconds or so. And you should have good pings on there. 200, 111, source, loopback 1, loopback 2, loopback 3, loopback 4. So let's see here. We got R7. Now if we go on the other side of our internet, so we're looking at it from R7's perspective, let's take a look at how we see things from R2's perspective. So 98.101. Let's see if we can ping that. Ping 98.101, source loopback 0. Oh, it dies, right? So let's see what we got here. Let's go on R2. Show IP interface brief. Let's just make sure we have 98.101 there. Okay, so that's good. Show IP BGP. Okay, so looks like I can get to 100, 100, 01, so that's good. Oh, did I? I probably did. Yeah, okay. Source loopback 1. Good eye there. Sometimes it's kind of weird trying to type and talk at the same time. Also, I'm getting bombarded with Gmail. So, okay. So we're pretty good as far as the internet's concerned. Any questions about what we've done so far? Let's take a look at what we have left. It's IBGP peering, we're okay here. We did all that. Injecting the networks, we did all that. And task 4 is coming up next. Okay, let's do this. Let's take a 2 to 3 minute break. I'm going to pause the video here just for a second. Pause this puppy. Okay, we're back with task 4, aggregating prefixes. So, So it's cool that we have 4 networks into BGP. So show IP BGP. So on R4 we flung those 100 something into BGP. That's 4 networks. Now you've just gotten a phone call from your service providers. They have called you up and they said you are a freaking idiot because you're advertising those separate /24s into the internet. Not cool. People are laughing at you. So you need to fix that by squeezing them down into an aggregate, which you normally call a summary, but in BGP you call it an aggregate. So we do that. Well, there's lots of ways to do it, but in this case, if we look at our topology, we've got the individual prefixes flowing down from R4 to R3, R4 to R5. So R3 and R5 are getting the 4 prefixes each. What we want to do is when we peer up to our ISP, we want to change that to 1. So 1 and 1. So thankfully I picked some pretty easy addressing scheme to make this a lot less painful. So how do I get 4/24s into one route? Well, that /24 is going to turn into a /what? Anyone know what a /24, assuming we got some, we're starting at 0, 1, 2, 3, want to turn that into one route. It's going to turn into a /22, correct. Now, I highly doubt that in the CCIE lab that they will give you such nice and easy addressing. One can only hope. But I don't expect them to be too crazy on you guys in CCNP. Okay, so going on, let's start on R5 first. Let's go to R5. First, we have to make sure that we have those routes in our BGP table, those prefixes, because if we don't, we can't aggregate them. So they must be known by BGP before we can actually squeeze them down into 1. Now, you don't need all of them. If all you have is one of them, you'll be okay. You will be able to make a /22. You just need 1. So, but in our case, we're lucky we have all 4, so that's good. And it's pretty easy. Conf T, router BGP 100. And actually, before we do this, let's go on R7. Oh, we already did a show IP BGP. You can do it again if you want to. So just take a look at your BGP table before. Go back to R5. Command is aggregate address. It's going to be 100, 100, 00. Mask /22 is 255, 255, 252/0. Question mark. What we'll do on this one, we'll leave it at default and see what happens. So we hit enter. Got some stuff there happening. Go to R7. And you'll see on R7 we have a /22. Right. So did send a /22 aggregate out there. Not a problem. But your ISP calls you up after that and says, you're still an idiot. Because now you're sending a summary and 4 extra routes. So yep, Jim's got it right. We're going to need to add in a little bit extra stuff. So we hit the up arrow, add in this word summary only. And you can see here it says suppressed. So it's basically holding them down. All right. He's been suppressed. kind of like that rogue LAPD guy that was in the mountains last week. He's definitely been suppressed. So go on R7, show IP BGP. And you can see right here, all you're seeing is that aggregate address. Yeah, speaking about that LAPD guy, he almost got out of there. Came so close. Okay, so we got a aggregate going out, so that's good. Yep. Chris, do you live up there in the mountains? Okay, so Raimundo has a good question. Can we do an aggregate address from R4? Does it need to be on the edge router? Well, we'll take a look at that after we finish with R3. So we'll definitely take a look at that. Usually you do it on the edge routers, but you know, we'll see if we can do it from R4. Oh, you snowboarding. Yeah. Craziness. Okay, now if we go to R2, show IP BGP, everything should still look normal here. We got no summary, no aggregate going out there. And that's because we haven't configured anything on R3. Because on this side of our connection, everything's still normal. So let's configure the aggregate on R3, and we should see it updated on R2. So we'll do aggregate address 100, 100, 00, 255, 255, 2520, and add in that summary only. And then R2 should update, show IP BGP, and we have a /22 and all the other prefixes are gone. Right. So let's actually take a look at R3. Go back to R3, show IP BGP. And you can see, oh, let me do that again. You can see right here, these 100 networks look kind of interesting. You see an S in front of them. S means they're suppressed, which means that normally they would show up, but because you have an aggregate, they're not going to show up. Any questions about the aggregate address? On the basic configuration is very simple. You're just taking a bunch of prefixes, squeezing them down. So let's go back to Raimundo's question. Can we do this on R4? Can we do this on R4? Well, let's take out our aggregate address commands from R3 and R5. So let's get back to normal. So R3 and R5, hit the up arrows and pop a no in front of there. And we'll wait for everything to calm down. R7, show IP BGP. And we're okay there. Let's go to R4. So R4, if we show IP BGP, we see our 100 routes in there. 100, 100, 00, 100, 100, 10, and so on. So let's see what happens if we try to do aggregate address here. Router BGP 100. Aggregate address 100, 100, 00. That's a /22 mask. Summary only. Okay. Now if we show IP BGP, we got suppressed routes there. So that's good. Got a /22. Let's go one hop further to router 5. Show IP BGP. And we have a /22 there. And we'll have a /22 on R3 as well. So if we send a /22 down to R5, then R5 is going to advertise just the /22 because it doesn't know anything else over to R6. So we can do this on R4. Not a problem. So it kind of depends on what your particular network setup is at. It might make sense to do it on R4 because, you know, less traffic through our networks. Less, well, not less traffic, but the BGP table is going to look a little bit cleaner on R3 and R5. Now if we go back to R4, router BGP 100, let's get back to that aggregate address command. Let's take a look at the question mark here. We got a couple things we could do. We could add route maps to pick and choose. We got not even going to mess with attribute maps. That's CCIE stuff. But this second one here, AS set, generate AS set path information. AS set, and then you could add in like a route map and all that types of stuff. But what you can do here, well, let's take a step back. When you're aggregating stuff, like Paul said a couple minutes ago, where it's cool that we're able to take those 4 routes and slam them down. But what could happen is this. Let's say these 4 links. So instead of loopbacks, let's say there were actually prefixes coming from different autonomous systems. So let's say 100, 100, 00 was ASN 600. 100, 100, 10 came from ASN 700. And you get the picture, right? So they come from different ASNs. When you aggregate them, you're going to lose some of that information. Because it's basically saying, oh, these 4 were separate before, but now I'm just slamming them down into an aggregate. So we should be able to see some of that difference if we go over to, let's say, R7, show IP BGP. Let's see if we can do 100, 100, 00. So let's see what it says here. Aggregated by, so it tells us that it came from R3. Let's see, 100, 100, okay. 3.1 came from router 6. That's the next hop. Atomic aggregate, and that's it. So now let's go back to R4. Let's kill that aggregate address. So no. And let's also make sure R5 doesn't have any lingering aggregate address commands on there. So it looks like we're okay. Go back to R7. Hit the up arrow, show IP BGP 100, 100, 00. Let's see if anything's different. Okay, so most of it looks okay. 66. So it says valid internal best. Before it said atomic aggregate. Okay. Let's go back to R4. Put back the aggregate in there. And so remember I told you guys that for you to advertise this aggregate, you need to have at least one prefix in that aggregate. So right now we have 4. But watch what happens if I start doing this. So interface loopback 1, shut. Interface loopback 2, shut. Interface loopback 3, shut. And let's stop at 3. Show IP BGP. And you can see that with 3 of them shut down, I have 1 left. I'm still sending this aggregate 100.100.00/22 because I have one guy, one prefix in that aggregate. All right, R7 is still okay. Show IP BGP. So we still see 100.100.00/22. So watch what happens when I do this. Interface loopback 4, shut. Now if I show IP BGP, notice that 100.100.3, so the address for loopback 4 is gone. Also the aggregate is gone because you don't have any BGP routes in 100.100. So BGP takes care of that problem. It just says, well, you don't have any prefixes in there anyway, so I'm just going to nuke the aggregate. No reason for that to be there. The thing cascades down to R5. And then if we go to R7, we'll see that it's gone. The 100.100.00 is gone. So pretty important concept to know about. Now, there's a flip side to that. So if all you need is one prefix in there, so if we go to interface loopback 1, no shut, interface loopback 2, no shut, I'll just turn them back on. Okay, so they're all back on. We know our aggregate flies over. Not a problem. But let's go on R5. Show IP BGP. So you need at least one prefix to be in an aggregate. So watch this. Let's say I do something crazy, like ultra crazy. I go in R5. So now I've gone completely rogue. I've had a bad day. I'm going to try to destroy the internet. And I do this. Aggregate address 98.0.0.0. My mask is 255.0.0.0. Summary only. Now before I hit enter, let's take a look at our BGP table on router 5. Do I have any prefixes in 98/8? Yes. So I do have several. Got 4. 98.100, 98.11, 12, 13. So I have prefixes in there. The rule is I can advertise an aggregate if I have a prefix in that aggregate. So if I hit enter here, now all 4 of my prefixes in 98, they're suppressed. If I go over to R7, show IP BGP, so now I'm telling the whole internet that that whole /8, hey, just hit, go over to me. Does anyone see a problem with this? I'm telling the internet for a whole /8, send into my network. Yeah, so what's the problem here? Let's pretend that YouTube was at 98,999. Yeah, YouTube goes down. Yeah, and I'll be advertising. I'll be accepting traffic for other people's IPs that I have no connection to. I'm basically black holing everyone. Everyone else on 98 is going to be black holed through me. All right. I could take it one step further. Let's go in R5. We'll take off that aggregate address. So let's save the world. We've hired a CCIE for $300 an hour to troubleshoot this, and he typed in one line, solved that problem, and now we have to pay him $1,200 because he has a 4-hour minimum. All right. Okay. Taking it one step further. What if I have a route in BGP? So IP route, let's say 8000. I'll make that a /8, no problem. And we take this into null 0. So right now we have a route in our routing table. Now, can I put this into BGP using a network statement? Yeah, sure can. Actually, I probably should have been a little bit more specific on that. So let's say IP route all 8s. If you're smart, you know what all 8s is. So we'll do that and make it an exact match. Okay. So I've got that static route, router BGP 100. I'll pop that into my network statement, network all 8s, mask 255. So I've got an exact match there. Goes to null 0, but I've got a match. Show IP BGP. So got something in there. So now with that null route, I can also advertise an aggregate address. So same thing. Destroy the internet that way. So whoever owns anything in 8 is not going to be a happy camper because all the traffic on the west coast of the US is now going to start going through me and my awesome 1 meg connection. So this is one of those epic screw-ups that, this is the YouTube screw-up that Pakistan did a couple of years ago. So they advertised, they fat-fingered it and forced all the traffic through them. So you guys can read up about it. What they were intending to do was null route it just for Pakistan, but then they advertised something different. So any questions about aggregate address? So it's good in the sense that you can take several prefixes, smash them down into one. Can be bad because you're going to lose some information. It can also be bad if you fat finger it. And if you want to learn more about the YouTube thing, you can actually go on YouTube and there's a YouTube video about what Pakistan did. There's also several blogs that talk about it. Pretty interesting stuff. Okay, we're coming up on 1 hour and 45 minutes in recording time. Any questions before we stop the recording and we go into extra credit mode? Okay, I'm going to end the recording. That's going to be Class 6 BGP Part 2. And stay tuned for next week. That's going to be Class 7 BGP Part 3, where we start doing some regular expressions and also some filtering, making BGP routes go different ways, just messing around with all the attributes and stuff. So everyone in the room, just hang on tight.